We'll do it live.
Okay. No.
We'll do it live. Fuck it. Do it live. I'll write it and we'll do it live.
James Webb can say is, ooh, a piece of candy, ooh, a piece of candy, ooh, a piece of candy, ooh, a piece of candy. When a ball turned into a vampire, all James Webb could say was, ooh, a piece of candy, ooh, a piece of candy, ooh, a piece of candy, ooh, a piece of candy. When he became Peter's best friend, they sat around the house and said, piece of candy, ooh, a piece of candy, ooh, a piece of candy, ooh, a piece of candy. And you know that James Woods practices lines real well, but everything that he reads becomes real hard to spell. Everyone tries to help him, but the words just won't come out. There's only one thing he can think of, and it's what comes out his mouth. Ooh, a piece of candy, a piece of candy, ooh, a piece of candy, ooh, a piece of candy. When he comes out of his house, the women scream and shout. Ooh, a piece of candy, ooh, a piece of candy, ooh, a piece of candy, ooh, a piece of candy. They know that he's not good, the best of them all when he says, ooh, a piece of candy, ooh, a piece of candy. A piece of candy, ooh, a piece of candy. Reese's Pieces on the floor and watch him come a saying, ooh, a piece of candy, ooh, a piece of candy, ooh, a piece of candy, ooh, a piece of candy. And you know that James Woods practices lines real well, but everything that he reads becomes real hard to spell. Everyone tries to help him, but the words just won't come out. There's only one thing he can think of, and it's what comes out his mouth. Ooh, a piece of candy, ooh, a piece of candy, ooh, a piece of candy, ooh, a piece of candy. When he comes out of his house, the women scream and shout. Ooh, a piece of candy, ooh, a piece of candy, ooh, a piece of candy, ooh, a piece of candy. Piece of candy.
I've seen things you people wouldn't believe.
So, a creature for my amusement. Prepare for battle.
Fucking thing sucks!
Oh yeah. Groovy gravy. We up in space, bitches. I got Starship Enterprise behind me, and I'm floating around without a spacesuit. How the hell that happened? What's going on, everybody? Welcome to Extra Bulla Science Edition. Been chatting with my pal here. I'm gonna introduce here in just a second. We go way back. We've known each other since the Earth cooled. I think it was before we had organic elements on the scene. I'm not quite sure what the fuck I'm talking about. Anyway, I want to shout out folks in the we got folks from all over the place here. Wonder Goon is here. Got Gamer and Ganja for Life. What's going on? Kim, my New York sweetie, what's going on? Lady. We got Classic Daddy 881. Who else we got? We got Kim, Jimmy Sinclair, what's up, sweetie? And we got Steve Wolfbrand, one of the best names in radio, although he's probably not in radio. It's great to say it in a radio voice. It's Steve Wolfbrand. Thanks for coming out. We're gonna have a fun show tonight. I just had my a little bit of liquid courage there, so I'm good to go for the night. About to introduce like I said, he is my first best friend. We tortured my father when we were children with our ADHD, but he loved us still anyway. No child services needed, thank goodness for that. He has a BS in physics from the University of West Georgia, an MS in physics, astronomy emphasis from Georgia State University, and an MS in geological sciences from Case Western Reserve University in Ohio. He's worked as the lab coordinator for the Department of Physics at the University of West Georgia, and currently is the General Lab Supervisor for the Department of Physics and Astrophysics at the University of North Dakota. Cripes, it's cold! His areas of research are planet formation and short period variable stars. I like to call him Dr. Science. Ladies and gentlemen, Mr. Rob Moore, how you doing, brother?
Hey, doing all right. How about yourself?
Man, I was been excited all week. You know, I've been wanting to talk to you for the longest time. I know you had the big move. You were coming from Ohio going to North Dakota, and I didn't want to get up all in your business, bug you. I wanted to get you settled in. I know that was like a few months back, and so I'm just glad that you're here, man. Because I'm probably like you. I am a big science nerd, but more of like a space science type nerd. But you're like actually school educated in the subject, and I'm ready to pick
sometimes
your
too much so.
Right?
Sometimes too much so.
Hey, no, man. Look, man, we need more smart people that don't act like dumbasses. So, and you definitely are not a dumbass. So I appreciate you coming on. So a little backstory for the kids in the chat here. Hey, Dolores, how you doing, love? Good to see you. Dolores is so great. She's always sharing shows and stuff for everybody in independent media and these independent shows. So appreciate her. So a little backstory for me and Rob here. Like I said, Rob is my first best friend. He was the first friend that I ever had. And I know some people are like,
Same.
Warren, right? We did see back in the day. We didn't have a kindergarten or anything like that. But did you go to like a church kindergarten or anything like that?
I did not. Nope. I went straight to first grade.
Yeah, me too. So When me and Rob met in first grade, and that was back in 19. It was I get the chest cold right away. I don't know what happened. Boy, this dry New York weather. Yeah, it's been a while. We hit it off because we were both at the time, we didn't know it. We were both pretty much ADHD kids, just very hyper, very silly, and you know it. But it was we knew we were gonna be friends for life. Even though through the years, you know, we've been apart, you know, different places in the country. I always knew, you know, we always, yeah, like when we were talking.
We find each other somehow.
Through the cosmos.
Okay.
Maybe on this starship here. Maybe this one here. Ow, we shot lasers. But yeah, it's like one of those kind of friendships that never dies. You know what I mean? We just like, it's more like we don't ever say goodbye to each other. We just say see you later. And so we were both Mississippi boys, and then you moved away. When did you move away? Like in 4th grade?
Let's see. Sixth grade. After 6th grade, because 7th I started in Louisiana, in Lafayette, Louisiana.
That's right.
So I can talk like a cool ass if y'all want me to.
He down there in the bayou with Boudreaux. Oh, go get that gator tail, slap you upside the head.
Yeah.
I don't know why I said that like that. That's my worst Boudreaux impression. Hang on just a second here. Anyway, so Rob moved away, but like you said, we've always remained free. We kind of hooked back up again in college, and this is the first time we've seen each other in a while, but we just picked up right where we left off all those years ago. It's like, you know, we never said goodbye or anything like that. What's up, Mariana? Good to see you. Thanks for coming out. But when we were kids, we always played Star Trek together. That's why I kind of got the Star Trek thing here. So it was me, you, and John Fulcher, I remember. And
Brian Ross would occasionally join us.
Brian Ross, yes. Yep. And but John would always be Kirk. You would always be you were Brian. I don't know. You kind of like switched out, would be Spock, and you always made me Dr. McCoy. You know, and I was like, look, dude.
We did.
The fuck,
I'm sorry.
man?
Looking back now, I'm sorry, man.
I've been waiting decades to say fuck you,
are much better.
man.
You would have been a much better Scotty.
Hey, laddie. Well, the way I drink now, I bet you I would be a good Scotty, eh? Although, I do want to get a kilt, just for fun, just to go to the DMV and take pictures for my license. So, and plus the air conditioning that you get under there, you know, the under chassis.
Yeah.
But you were always like, you were always big into like science-y type stuff, especially like dinosaurs. I remember you were huge into dinosaurs, and I always knew you were going to do something, like you were going to be a scientist when you grew up. I just knew it.
That's where my start was, for the love of it, you know, dinosaurs.
Yeah.
So
yeah, it started with dinosaurs. So I was about to say, how did you actually get into being in the physics realm?
Well, it started with the kids' love of dinosaurs. This is why I encourage it, like with my nieces, nephews, and cousins, and you know, any kid I come across. Love those dinosaurs. But my dad pointed out to me, well, be a paleontologist, you have to be a geologist. Oh, so I'm going to be a geologist. And then studying up on that, looking at rocks, and learning that there's igneous and metamorphic and sedimentary and all this other stuff. I found out eventually that there were then 8 other of these bodies in space called planets. Oh, that's astronomy. Oh, I'm going to be an astronomer. And so that's really and truthfully, you know, from the love of astronomy, well, to be an astronomer, you got to be a physicist. So I'll be a physicist. And that's kind of the whole train, and it getting derailed. But along the way in there, what really turned me on about astronomy was how do we get planets in the first place? And so that's what led back to the planetary sciences of the geology is to make a planet, you kind of got to study what a planet is. And so, that's the whole trip around. It all came in a circle.
It came like a planet. A planet is a circle.
Yeah.
Although a planet's not perfectly round, right?
No, they're not. There's a lot of factors that go into that, but one of the big ones is if it's rotating at all, like Earth does, then it kind of flattens and it spreads out at the equator and flattens at its rotational poles. And you can see the effect of that, by, hanging onto a merry-go-round. And as you pull in, of course, it goes faster. And as you go out, it slows down. And so that's one of the ways that planets and all bodies even out what we call angular momentum, is by trying to bulge a little bit. So
now Rob, we know better. We know that the Earth has a little bit of a cookie problem, likes to eat cookies, and it just goes straight to the hips, right? That's why there's the bulge, right? That's it's space. The Earth's eating space cookies, isn't it? Right?
Eating space cookies. It did early in its life, and it just has not lost the bulge yet.
See, folks, I set him up and Rob knocks him down. I'm going to ask Rob some really dumb questions tonight, and he's going to he seems to be very nice to me, and I appreciate that. And he's going to correct me very gently, hopefully. Mm-hmm. He's going to cradle me in his educational arms and say, "No, dumbass, this is how it really is."
Hopefully, nothing will come out that'll be that bad, but
In any event, I still want to be cradled.
Okay.
I'm good like that. So before we go any further, so Rob moved away in junior high, but he did come to my high school graduation back in 19, and then so we got to meet up again, and now you get to see what we look like back in the day. Back in the day. Oh my. Look at that. That's, as the cow says, that's utterly delicious.
Back when I had hair and there was less of me.
A little less than me too. I had the Rick Astley thing, got the butt cut going. So yeah, 18 years old, just graduated college, high school, and my bud Rob came to visit, and yeah, man, boy, look at you, man, you had like that George Hamilton tan too, man. Look at that. Yeah, man. I'd look at the sun and just turn red, and then be back to El Blanco, man. It was just awful.
Back then, I had time and everything, no bills to pay or anything like that. You could lay out in the sun all summer long. So, and summer comes early in South Louisiana and Mississippi.
Yeah, it's pretty fucking hot down there too, y'all. Yeah, this was in South Mississippi, home of the humidity factory. So yeah, but I figured we go to take a little trip down memory lane there, for that fun. But, like I said, we're gonna get in some, other fun here too. So when do you remember the physics guy that, I don't know, they would show in the science classes, they would show us videos of, Julius Sumner Miller. Do you remember that guy?
I don't, actually.
Really? Huh.
Julius, I don't remember him, but Julius Sumner.
Oh, no. There's no need for the tippy-tappy. I got you covered, okay? So, all right, so in the science classes, I think this may have been to late junior high, early high school. There was this guy, and he'd been around forever, right? His name was Julius Sumner Miller, and he looked just like the dad from Laverne and Shirley. Mr. DeFazio. So, and I would always say that, and people never would get the reference, and then I'd just, go back into my corner and cry and,
Cry. Yeah.
cry tears of failure. But they put a little something together here with this guy. I don't know, maybe this will jog your memory here. Let's see. We got a whole bunch of stuff here in the thing. So
I can see what you mean with looking like Mr. DeFazio, but
yeah, you'll see. Here we go.
I remember that opening.
How do you do, my friends everywhere? Ladies and gentlemen, and boys and girls, and teachers and peoples, and mothers and fathers.
Look at that guy.
I am the Professor Julius Sumner Miller, and physics is my business.
Physics is my
And
business.
here is a strange one that many do not believe. Consider having two bodies, A and B, say, on the same horizontal level above the floor of the earth.
It's a little jerky, but...
Let us say that we are equipped with some mechanism to let this one, release this one to fall freely, whereas this one is shot horizontally with some horizontal velocity, which I will label v sub h. Now you know it takes the path of a projectile, which is a parabola, and
Do you remember this guy?
you know too, I hope,
I remember this
that
guy now.
ideally
Yeah.
speaking, they reach the ground in the...
I remember having absolutely no
Now,
idea
some
what
of
he was
you
talking
are
about.
troubled by that. It is true. It is true. The proof
See,
could
the
be
kids
made
grew
very
up with, like,
simply,
Bill Nye and,
linguistically, but
what
we
was
have
his
some
name?
apparatus to prove it experimentally within the limits of our observation,
And,
acoustically and
those
optically.
guys.
But
we
here's
had
the
this
answer.
crazy-looking guy. Looked like he was sniffing
A
glue.
philosophical proof. Supposing
Yep.
there was no gravitation. We have to imagine. In some time, the body would be there.
That's enough of that guy. So, anyway. So, yeah, Julius Sumner Miller, science or physics is my business. And what was great about those videos was that he would do an experiment, and he would say, well, now as the motion goes through the air, as the force strikes, that didn't work. But he was kind of like the precursor to Professor Frink from Futurama. You remember, Professor Frink will make you laugh. Although he was from The Simpsons, I think. Yeah, he was from The Simpsons. He'll make you laugh, he'll make you think, hey, the Haven. But yeah, he would do like experiments, and he said, now this ball should go into the tube. Oh, well, it didn't that time. But if it did, it would it's like, come on, man.
But if it did,
He was the Ed Wood of physicists, right? He was like one
Okay.
take. He said, screw it, we're not doing this again. We're just going to do this in one take. So, I figured you would enjoy that a lot.
and that's the scary thing about physics is quite often doing demonstrations in class, the stuff never works quite
Right.
the way you anticipate it. Because as I tell students, what we anticipate dwells in physics land. It's the world of, frictionless planes and airless vacuums and all this. What we deal with in the real world is the real world. And there's all kind of crap going on with the real world. Physics land is the land of the textbooks. It's right next door to Never Never Land. Peter Pan stops by for tea. And this is why some people just don't get physics. That's not what happens when I try these things. Well, if you try them enough times, you'll see that it actually does. But on any one time, no, it's probably going to something go wrong.
No. So do you get to teach classes or in the time you've been doing this?
Currently, no. I teach only some labs. But in the past, I have taught intro physics classes. And I get as nutty as you're seeing me right here. I get crazy. I tell them stories. I tell them, about that physics land is right next door to Never Never Land. But then I proceed to show them, this is the equation you would need if you want all these real world factors So here's what you know and what we've told you, and here's what you do when you add air resistance, and here's friction, and here's all of a sudden the equation takes up the whole board. They're like, now, do you understand why we keep things simple for you? Well, they may not work exactly right, but they get close enough. And usually I get a bunch of wide eyes and nods, you know.
They're like, oh, so like horseshoes and hand grenades, right? Close enough? Yeah,
Right.
yeah, close enough.
Close enough.
I just want to tell people in the chat, what's up, Troy? Good to see you. And Wonder Goon, did we already say hi to you? Hello. If not, hello again. If you guys have any questions in the chats for who I affectionately call Dr. Science here, feel free to put them in the chat. If don't be shy. And
Absolutely.
hopefully he'll be able to answer those questions. But let's get to the meat and taters of tonight. There's been some things that I wanted to talk to you about, just to a scientist in general, but particularly you, because like I trust your judgment. You're not one of these guys that you have like no you don't have an agenda or anything like that. I know you'll tell me the truth about things. So, and that's kind of comes at a premium these days, as you well know.
Yes.
The truth. So, so we'll talk a little bit about the heavy stuff first. Let's talk about climate change. Now, you had told me before we went on, you kind of like changed your thinking on it. You were kind of skeptical at first, but now you're in a place where you're like, yeah, it's for real. Like, what do you think is going on right now as far as like climate change is concerned?
Well, unfortunately, what I think is that it's gone too far. There's not a whole heck of a lot we can do at this point. I'm one of those pessimists. The problem is people, well, climate's always changed throughout Earth's history. Yes, it has. It doesn't change on the scale of hundreds of years as the problem. And that's what we're seeing. And that's what people aren't getting, is that, yes, this is no different than any other climate change in any other time period in Earth's past, except it's happening very, very, very quickly. And how do we know that? Well, because things like, you can get calcium carbonate to form two different types of minerals, and the only difference in which one forms more than the other, whether it's dolomite or what's the other one, calcite, I think it's calcite, is the temperature. So we've got several of these types of mineral pairs that we can use as thermometers to say, here's what the temperature was like in the past. And what we're seeing is that it normally takes tens of thousands of years for temperatures to change like we're seeing them change now. What we're seeing now is changes on the order of few hundred years. And what can you say, but what's changed? Well, let's see, the past few hundred years, what's changed? Us. So, when you add in that, despite what people think, all the natural sources of CO2 going in the air, we're putting about 100 times more per year in the air than all of those natural sources. The data is there. You can doubt me all you want. You can go look at the papers. It's there. It's real. And that's what led to me being convinced, is looking at the data and saying, oh, crap.
So you're saying it's too late, right? We could carbon emissions till cows come home, and it's pretty much irreversible at this point. There's merit to cutting carbon because that will cap where it goes to. When you think about it this way, if we burn all the oil that was there, is on the planet, and all the coal, this is stuff that was laid down during what's known as the Permian period, about, 600 million years ago? Yeah, roughly. And from our mineral markers of temperature,
the Earth was about 20 degrees warmer then than it is now, 20 degrees Celsius. So if we burn all of it, the Earth's probably going to go back to what it was when the Permian period was around, about 20 degrees Celsius warmer. Right now, you're hearing them talk about 6 degrees. We could probably, if we could slowly start tapering off and wean ourselves off of these fossil fuels, we could probably hold to about 4 to 6 degrees increase in temperature. But cutting it to 0 right now, the temperature's still going to go up for the next few decades at least. And so I'm not a big proponent of cold turkey. But should we be doing something? Yeah. I mean, how bad does it have to get before you finally start saying, you know what, maybe we ought to do something?
Yeah, I mean, doing something is better than doing nothing, at least like to try and minimize it as much as possible.
Right.
But that kind of leads me to the next thing here. But first, Atris in the chat here, that asshole, he wants to know if the Earth is flat.
Oh, Lordy, that question. If you're serious, man, all I can say is I do not engage on that in question anymore. I will engage as far as to say, no, the Earth is round or roundish.
Yeah, because of the cookies, right? The cookies at the hips.
The cookies. I can list 1,000 more. I mean, the ancient Greeks knew it was round. Okay? Eratosthenes measured the circumference of the Earth to within 20% error using a stick and a knotted rope to measure distances with, and got within 20% error of the actual circumference of the Earth. And this would have been 200 BC.
Wow.
So don't come at me with this. Oh, the Earth is flat. Ha ha ha. Sorry, no, you're wrong.
He's being an asshole, which is fine. That's most.
I am being an asshole on that. On that one, I'm sorry. I do get a little assholeish, but
well, he's being an asshole. He's being an asshole too, but he's a good asshole. There's like two kinds of assholes. There's like the good assholes, and then there's like the fuck you assholes. But he says I like this guy more than Neil deGrasse Tyson.
Well, thank you. I will take that as a compliment because I've met Mr. Tyson and he can be an ass.
Yeah, fuck that guy. He killed Pluto, man. Oh, it's not a planet no more. It's not a planet no more. Asshole. Anyway, no, that was a good question, Atris. Thank you for asking that. Yeah. But the temperatures, it brings me to this. I do a show do a news show on Wednesday mornings on Kerberos Media on the YouTubers with the lovely and talented Jimmy Sunderland, and we did a story about this glacier that's in Antarctica they call it the Doomsday Glacier. Because of rising temperatures in the seawater, and it's kind of like a dual threat. The water below it is warming and melting it, and the temperature above is melting it too. So if nobody knows what I'm talking about here, let's we got another little video. Hopefully this one will play better than Laverne's dad. That one was a little bit off kilter, but this is kind of scary to me. So. Just take a listen here.
This decade, a handful of people that I've worked with have never come back from here. This is extremely dangerous.
Thwaites Glacier, otherwise known as the Doomsday Glacier, is bigger than Florida and attached, for now, to the West Antarctica ice sheet, which itself is bigger than India.
Thwaites is unique in that it's melting faster than any other glacier on Earth, and it's at the same time the one we think is the most vulnerable. It has a kind of an unusual shape in that when you start at the coastline of Antarctica at Thwaites and you work your way inland back to South Pole, the bed underneath it, the seafloor becomes deeper and deeper. So as it melts, there's more and more ice to melt. So it's a runaway, unstable glacier that right now might be right on a knife's edge and may in fact pass that point.
The knife's edge for Thwaites is when it melts and collapses, an ominous event lurking somewhere in the future.
Thwaites does hold the possibility to change the global coastline by something of scale 3 meters, say. Florida, for example, only has an elevation of about 3 meters. So we're talking about a massive potential change on the planet. When we arrived here a couple of weeks ago, a massive iceberg, some 40 by 30 miles wide, blocked our icebreaker from getting close to Thwaites. So we're in Plan B now. We're studying a glacier next to Thwaites. The physical processes are similar, so we learn a lot by studying this one. Last night, we drilled down to this ice sheet with that tower. We put a temperature sensor down below, and right now it's 500 meters below my feet, down in the waters of the Pacific Ocean.
Glaciers are losing mass around the world. The Antarctic lost 51 billion tons of ice between 1992 and 2001. That amount nearly quadrupled between 2012 and 2016 to 199 billion tons. The melt is responsible for alarming sea level rise, putting thousands at risk. In the U.S. alone, nearly 30% of the population lives in coastal areas.
What it's all about here is collecting data so we can do a global glacier sea level forecast. At airports around the world, there are temperature sensors, and then there's something called the weather equation. It's a mathematical equation, and that is the forecast that shows up every day on your television or your iPhone. And this is an attempt at solving an equation that's way more difficult, a glacier equation.
So yeah, and basically, the long story short of this is, like we were talking before. So, to those who don't know, Antarctica is kind of like two different types of firmament. You have like the east side that is mostly land with like about a mile or so thick of ice on top of it, and but the western part is like islands, right, with ice above it. So you have water flowing underneath that's melting.
Right.
So
and let me just throw in. Sorry to interrupt, but let me throw in.
No, go for it.
That you remember that ice does what on water? It floats, right? So as it gets more water underneath it, it floats up, which lends to it, instead of creeping along at a few centimeters per year movement, all of a sudden it can just zoop and slide right over. And so that's what we're seeing happen, is that it's actually getting more water than we anticipated up under these glaciers. And they're just, flowing like a river right out into the Pacific. So this is something that you've got to watch out for too. It'll take decades, 100 years for those glaciers to melt and slide off into the ocean. No, it may not.
Right, and they were talking about like we were talking about this before. The ice shelves that's keeping it in place is kind of like the doorstop, or they were calling it the cork that's keeping it in place, and that's the thing that's probably going to go tits up within the next 5 years, they said, which is very terrifying because that's how, because this thing is as big as Florida, and Florida is not a small state, and so you're talking about the size of Florida, about roughly 3,000 feet thick, I think is what they said. Here, I'm gonna request it.
Okay.
I mean, like, it's not consistent. I know it's like thinner in some places. That's the link to that video in the chat, guys. So, but I mean, what does that mean for like coastal areas around the country? I mean, like they're talking about at least sea levels rising 2 feet, right?
Right. Well, they said 3 meters, so roughly 9 feet.
9 feet, yeah.
9 feet. Now, here's the deal. That water has to distribute itself and dissipate throughout the entire ocean. So again, these changes are not going to happen, bam, as far as our lifetimes are concerned. And I think that's part of why it's hard to get people really agitated about this, is we think in long term is 5 years. Well, it may take 10, 15 years for this to spread out enough that Florida gets flooded. The trouble is it's coming. It's going to happen. And that's kind of where I'm at with my pessimism is. It's not that it can't get worse if we don't stop, but it's going to get bad whether we stop or not now.
Yeah.
And this is something that glacier's going to go. I mean, even if we stop cold turkey now, the ice on the ice shelves is melting too fast. It's kind of like the Arctic ice here in the north. You know, it's disappearing rapidly, and during the summers now, the North Pole gets ice free. The North Pole gets ice free. What? Holy crap!
Yeah, you see,
And,
like polar bears and stuff looking for places to go. You know, they
Right.
have to change their migration and like change their feeding grounds and stuff because there's, you know, they were so used to having that ice to travel on, and now it's practically gone, right?
Right.
Yeah.
So that's the thing. You know, life will adapt, life will change, but we're not giving it time to change and adapt, and that's the big problem. And what do you do?
Well,
And somebody is bringing up a good point. The sea level change will change more in certain areas than it will others. More of it will stay because of the equatorial bulge at around the equator. So they're not wrong in that. So this is why I do naysay to some extent all the predictive models. We don't know exactly how bad it's going to get. Okay? But it's going to get bad, and we know it's happening. Screw the models. You know, don't concentrate on them. We don't know. We don't know enough to be able to make a perfect model to predict what's going to happen.
Yeah.
But it's going to be bad, folks.
Yeah, I mean, everybody expects like Roland Emmerich films, like 2012 or the day after. Was it the day after tomorrow or something?
Day after tomorrow. Yeah.
Stuff where it's gonna freeze instantly and stuff. It's like, nah, it's not gonna do that. But there's gonna be some crazy shit happening. So now we're gonna leave Earth here. We're gonna get in the shuttlecraft and go up to the Enterprise here.
Okay.
And
beat me up.
I used to freak people out when I did that. They always said like, you sound like a cat on meth. What's wrong with you? Like,
I'm a cat on meth.
I'm a cat on meth. I mean, you know what? So you know, so we're up in space here, and you know, I'm a big fan. I always tell people I'm a big fan of the apocalypse. I'm just not sure which one's coming, but one's coming.
Right.
And you know, pick your poison. So if we're not gonna get flooded out right away down here on the Mother Gaia, what's the chance of us getting hit by another rock anytime soon, right? So I pose this question because I want to talk to you about this guy, and let me get this here. Dad's slow with the tech. Should have ate his Wheaties. I heard about this back, I think it was 2014? I think that's what, or maybe, no, it was 2004. I think the asteroid Apophis. The asteroid we thought might hit us. So they've updated this. This is from September 22nd. So basically there's a big rock coming at us. I think it's 2029, around April 2029.
Something like that.
It's supposed to get fairly close, like within like what, about 20,000 miles from Earth, like under the satellites, right?
Right. It will be coming underneath a lot of our satellites that we use for things like GPS and so forth. So yeah, it's going to get quite close.
So this is a rotational meteor, right? This is going around the sun, and it's supposed to come back again in close proximity back in 2036, right?
Right.
At first they thought they were giving it like a let's see, I think it was like a 2-point-something% chance it was actually going to hit in 2029, but the new models came out and said it was going to miss us. But there's still a risk of it hitting us, right?
The models aren't 100%. You know,
right.
This is the real world, not physics land.
Right. Because from what I've seen or what I've read about here is that there's a gravitational keyhole, right?
Right.
That if
that's even what they call it. Yes.
You want to explain that, like how that could affect its trajectory and whatnot?
Okay. And what that keyhole it represents is there's a certain coming close to Earth like that. Earth's gravity is going to perturb its orbit. It's going to shift it. Okay. Now we can calculate and know within very narrow margins what its orbit would be like if it didn't pass close to a large body like Earth. Okay? But it's going to pass close to Earth. It's going to be passing close to the moon, which the moon is a fairly large body with a lot of mass, and it's going to get close to it too. So with that many factors going on, it actually becomes very difficult to tell where it's going to be. But you can narrow down a nice keyhole where if it passes through that, oops, we're on target. Now, is that 100%? It's pretty close because, you know, we're able to narrow it down. You know, we can't 100% say, well, it's not going to hit us, but we can pretty well say 100%, well, now it is. And that's what the keyhole is all about, is if it passes through this zone, well, now we're like nearly 100% confident it will hit us. Whereas anywhere outside that zone, we're 99% sure it won't. So that's what the keyhole is all about. It's just using these orbital mechanics, these basic laws of physics, and applying margins of error and saying, here's the zone, here's the surface that if it penetrates that, it's on target to hit us. It'll fly around and come back around and smack.
So if there's a good possibility it hits this keyhole 2029. It's definitely not going to hit us in 2029, right? So, right. But it could hit this keyhole and possibly 2036. And even though, and from what I've read too, even if it misses us in 2036, there's a really good chance in like 2060 something, like 40 years from now, that it's like
an even better chance.
It's an even better chance that, you know,
the keyhole will actually be larger then than it will be this past. So, yeah,
I'm just glad we're old, and unfortunately,
hey, I've got grandkids though.
I know. Well, we got it. Well, we got to get them away from the coast, and we got to get them in those underground tunnels that they have under the Denver airport, because you know that shit's there.
Right.
There's all that shit's down there. You know, get them up to Wyoming into the tunnels. They'll be fine.
Yeah.
They're kids. They're your grandkids. They're hardy kids. They'll know how to survive.
That's true.
I got Steve Wolfbrand. Steve Wolfbrand in the mornings on KQOH. I just made that up. There's no call letters like that. He's talking about. He wants to know about Oumuamua. Which is a favorite of mine too. Do you think it's extraterrestrial? Well, it is extrasolar, right? But do you think it may be like intelligent design? In your opinion, educated opinion.
In my educated opinion, no. But I'm willing to be. It's odd enough that I'm willing to be convinced.
Right.
Okay. It's like a lot of things in the world. It doesn't look. I don't see enough to make me go, yes, that's something that an intelligent civilization created. However, it's odd enough to make me go, but I wouldn't be surprised if something turned up. You know.
Well, it was doing some weird stuff, right? It was doing some abnormal stuff that space rocks don't normally do, right? Wasn't it like didn't it accelerate once it got past the sun, but there was no trail? It wasn't like a comet. It didn't have like an exhaust. I mean,
that's what happened. Is it didn't have a trail. It didn't act like a comet. and it came from deep space, so it should have been cometary, and it didn't do that. It was more like an asteroid, where there should be no rocky bodies out on the edge of the solar system. So that's the deal. What made people start questioning is it didn't actually accelerate or decelerate or do anything like that. It just didn't behave like we expected it to. We expected it to be like a comet, and instead it was like an asteroid. But it came from where comets come from, not where asteroids come from. So it was like, that's weird.
Did it come from so you have like the solar system, you have like the planets, and you also have the what is it, not the Oort cloud, that's way out
there, the Kuiper belt. Depends on how you want to. Yeah, that's where Pluto and your Neptune are.
Right. My anus is down here. Eyes are up here. Okay.
Right.
So I love a good. I knew I was going to get a Uranus joke in here.
Absolutely.
So Wonder Goon on Twitch, he wants to know, or she wants to know, or they want to know, can Apophis be moved potentially with a DART, DART like mission?
And the answer to that is, that's what we're trying to find out with DART. The answer should be yes. So if Apophis ever comes through, if DART is successful, we could probably anticipate if Apophis comes through and hits one of those keyholes, we'll almost immediately launch a mission to send something up there to launch a projectile at it to nudge it off course. And that should hopefully make it go whiz by again and miss. Woo.
Yeah, so it's not like Armageddon where they got to send like space miners up there to blow it up and stuff, right? Okay.
No.
I figured as much, but I didn't know if the kids did or not. So. In fact, blowing it up could actually probably be a useless gesture or worse. And everybody ends up going, yeah, but everything will burn up in the atmosphere. Okay, so you want to be shoved into a 250-degree oven? Because all that energy is still incoming. It's still going to hit. It's just going to burn up in the atmosphere, heating the atmosphere. So you want to be inside of a 250-degree oven is what you're telling me. Not unless I'm wearing like Bermuda shorts and it's a Saturday night.
Yeah, exactly.
I do love a hot night, ladies. Had to drink some of that cool water after that. So get back to Oumuamua. So Steve he said it acted like a space sail. So it had like a weird shape to it, right? Then they say it was like flat, kind of like it was long.
It's flat, not long. Yep.
Right. And that's very odd for space trucks shape, right?
It is. We've seen nothing shaped. We see nothing shaped like that in our system. So, it is a puzzling object. And there are proposals to say, hey, let's build a probe to launch after it, and study this thing. Because, as has been stated, it is definitely extrasolar in origin. And, right now, all we've really got is a lot of guesswork. It did behave a little oddly. It did do some strange things. What's going on? There's
always been talk about you've heard of Planet X, right? That like it's supposed to be it was supposed to be the 10th planet, but thanks to asshole, it's the 9th planet. That
still
guy
bitter about that, huh?
Bit him too. Yeah, piece of shit. Fuck that. Pluto forever. Never forget. But so do you think there's a 10th planet out there, like some like that has like a huge orbit or something, just something we haven't seen yet?
I'm willing to be convinced. That's all I can really say on that. I can tell you why I don't really believe it's there. And I'll start out on that discussion by just saying we have done all sky surveys in the infrared. In other words, we've taken a telescope that sees in the infrared, and we've taken an image everywhere. And there is nothing large moving out at that distance other than a few bodies like Pluto that are about that size, and there's several of them, but there's certainly nothing the size of Neptune like I think somebody was hypothesizing needs to be out there. And because a Neptune-sized body out that far, because Neptune radiates more heat, more infrared, than it absorbs from the sun. So thanks to this being an infrared, this dim, what would be a dim little dot in optical in what we see, is a bright star in infrared, and we don't see anything like that. So,
I mean, could there be like a brown dwarf? Like, because isn't it true that like most solar systems are have two stars, are binary?
Binary, and that is it is possible, but again, it should be glowing nice and brightly in infrared. It may not be glowing in visible wavelengths, but it should be in infrared, and we've scanned the sky in infrared. Nothing is there. So, to me, one of the big things would be is you'd have to come up with an explanation of why that is. Why isn't it glowing in infrared like it should be?
Yeah.
And so it falls firmly in the category again of I'm willing to be convinced. Show me something besides a lot of pretty mathematics that say that the Oort cloud and the Kuiper belt are being pulled in the wrong direction. That's what they've got right now.
Well, wasn't there like a disturbance in like in the gas giants? Like something was messing with Neptune. Was like that, or maybe like something was perturbing their orbits, or
that
some sort.
That was something. Yeah, that was something that was hypothesized and calculated. Oh, when was it? Back in up until the 1920s, just before the discovery of Pluto. Yeah. And that's why one of the reasons Pluto was called a planet from its discovery, is because they thought they'd found it, and then they started finding out how small it was, and were like, "Oops, no!" And they went back and looked at their math on Neptune and realized, "Oops, somebody made a mistake in the calculation." And
they opened up a box of Captain Crunch and it said, "Oops, all dwarf planets."
Right. So they found out that there was they found out that there was no perturbation in Neptune's orbit. Is the end result. And but that's one of the problems with the redefining of Pluto is Neptune is a sizable perturbation on the orbit of Pluto.
Well, which one of the planets has the, I can't remember, was it Neptune? That has, its rotation goes like north-south instead of horizontally, it goes vertically?
That's Uranus.
No, that's Uranus.
Yep. Okay. We're going to keep going there, are we?
Yeah, we're going to keep going back to Uranus till we plug it.
Okay.
What? But what caused that though? Since like all the other planets, they rotate horizontally. Why is it doing that? Was it like something in the past that Jupiter did, or how did that happen?
It's the current hypothesis, as far as I know, is still that it was struck by something roughly the size of Earth.
Right.
So now that is a running joke among us astronomers because. We can't explain why Venus rotates so slowly. Giant impact. We can't explain why Earth has such a large moon. Giant impact. We can't explain why Uranus rotates on its side. Giant impact. And so there's kind of a running joke there of, you can't explain something in planetary science about our solar system. It must be a giant impact. So I hesitate to say that that's what it is, but that's the current dominant theory, and our hypothesis, I should say. It's not a theory because it hasn't been tested or shown to be true by other observations. So it's just a hypothesis. But it's another reason why we need to go out there. We need to send a Juno to Uranus and Neptune and see what's going on with these ice giants. So
So if an ice giant made a big impact on Uranus, okay, I'm not going to do that. Anyway, sorry about that. So, but that really does. I know, right? We're going back to junior high. But there was a in the past. Did they figure out that there was like a collision, like Earth was like a super Earth at the time, right? And then there was a collision, and then that protoplanet, what was it, Theta, or what was Theta? Thea. That crashed into it, became the core of the Earth, and then everything else, the remnants became the moon. I mean, is there any credence to that?
It's the best. It is the best theory that fits the data so far.
Right.
Okay, and that's why it is a theory. Is because there is supporting evidence to say yes, this is what happened. So right now, that at least the formation of the moon does at least boil down to a giant impact with an early Earth, and the models and the observations and everything, because there's a little bit of what's called an isotope difference between the moon rock and between the Earth rocks, and all of that seems to indicate that the moon was created from a different body than Earth. And so that is one of the things that leads them to believe that Theia came in, and the moon was formed mainly from material from Theia.
Right.
And Earth absorbed the rest of Theia and became the planet that we know and love today.
This was early on in the formation of Earth, right? This was like within the first couple, maybe the first billion years.
200 million.
200
not even a billion. A few hundred million. Yeah, it would have been happened
too, right? It was
right.
It was a super Earth at the time, right?
No, it was actually smaller than what it is now.
Oh, it was smaller.
It absorbed most of Theia.
Okay.
So there's a few things that we know are going on in the center of Earth that we think may be remnants of the core of Theia and everything settling into the core of Earth. And but there's lots of nice little supporting evidence. The fact that the moon has a different ratio of oxygen isotopes than Earth does. The fact that the moon is definitely pulling away from Earth, which means at some point it was in closer, and just lots of nice little things like that all point in the same direction, that the moon was indeed generated through an impact.
So have you seen the new movie Moonfall? Speaking of Roland Emmerich, have you seen that movie?
No, I haven't seen that movie. Interesting. Is that literally what it said? That the moon came crashing back?
I'm not going to spoil it, but
okay.
It's how can I talk about it without spoiling it? But okay, so is it possible that the moon is an artificial satellite at all? The reason I asked that,
with almost 100%, with as much certainty as you can ever have in such things, I'm going to say no.
Was it the United States or somebody had shot a rocket into the moon, or it was like a satellite or something? They shot a projectile at the moon, and they said when it hit, it rang like a bell. Do you know?
Yeah, and I can honestly say to you that the Earth does that. We shoot projectiles into the Earth's surface all the time, and it rings like a bell. It's called seismic waves. It's like an earthquake. And yes, we have indeed done the same thing to the moon and made it ring like a bell. And we've got seismometers thanks to the Apollo missions. And so, yeah, that's how we tell about that's one of the main ways we tell about the interior of these bodies, is to get a seismometer on the ground. This is why the new one that was with that latest rover landed on Mars, why it was such a big deal, is because we can use the waves that generated by the earthquakes penetrate into the depths and how they're reflected and refracted tells us what's down there.
Right.
And so, you can describe that as ringing it like a bell, because if you walk up to a bell and you ting it, it'll ring. If you fill it up with concrete and you ting it, it'll still ring. It just is more of a thud. But it's still vibrating and shaking.
Tunk.
You're right.
Punk.
I'll tell you what, let's meet up in Philadelphia. We'll fill up the Liberty Bell with concrete. They won't mind.
No, man. Yeah, I'm sure they're just fine with that. Which one of us is going to bring bail money? That's all I want to know. But
there you go.
Just food for thought. I would say watch Moonfall, but wait till it comes to like your favorite streaming service, because I think you will get a kick out of it. You'll just be like, "Oh, Roland, you've done it again."
It cannot possibly be any worse than the movie where they talked about drilling down to the Earth. The Earth's core is stopping. So to get it started again, we're going to drill down to the Earth's core, and we're going to take all the nukes in the world with us, and we're going to nuke the core and get it start spinning again.
The core.
Because
the
core, that was its name. It cannot be any worse than that.
Core. How dare you desecrate the core, man? Yeah, it's pretty bad. 2012 was pretty silly too. I mean,
we in a physics class, physics seminar where students give talks, a student presented about the bad physics of that movie, and we actually had people sitting there in the seminar class, Googling how much each nuclear warhead, what energy it would provide, and multiplying it by the number of warheads we had, and figured out that the core, if you detonated every nuke in the world on the edge of the Earth's core, the Earth's core would look around and go, "Did something happen?" This is why I tell people, we do go to nuclear war. The Earth is going to go, "Did something happen?" We're the ones that are going to be SOL. Okay.
Yeah, I know.
The Earth isn't going to care. We're in trouble.
Right. I mean, the Earth will heal itself, and
right.
I mean, with recent events, it seems like people are trying to test that theory, so they're trying to make it a theory, and hopefully it won't. But now, all right, so that was some fun talking about the fantastical stuff there, but some of the science in there too. Now let's talk about some real fun. The James Webb Space Telescope.
Love James Webb.
Okay, so this thing. No, I figured you would. I was very this is like the Lamborghini of telescopes for you. So.
Oh yeah.
But the Hubble had a good run, right? But it's this thing.
The Hubble is still running, but yeah,
still running. So what is the great advancements on the James Webb that are different from Hubble?
Okay, number one, you've got to remember, James Webb is an infrared telescope. Now, what good does that do? Well, the dust and everything, the gas and the dust that is out there in the universe absorbs invisible light and better than it does infrared. So infrared light gets through all that dust and garbage, and visible light doesn't. So James Webb seeing in infrared is a huge advantage because it can see further through the dust. Okay? So that's one thing. Number two, it is much larger than Hubble. Hubble has about a meter mirror, I believe, whereas James Webb, I forget how big it is. I'm going to have to look it up. Sorry.
Science. There's like, how many, there are like 18 or 20, how many mirrors are on that thing?
It's a segmented main mirror. Oh, it's 6.5 meters. So about 21 feet across.
And this thing folds, right? It was folded to get it up into space, and then it unfolds, right? So how does all that work?
Okay. So here we go. Basically, the outside edge just unfolds, then I think the tops and bottom unfolded, okay? And because it's in segments, each one of those mirrors now focuses on a different place. So the first thing they had to do is adjust the positioning of each of those mirrors one at a time while taking an image so that they could see which mirror, they got bottom line 18, I think it is. I think there's 18 segments, 18 images of this star. And they move one of the mirrors and see which one of those mirror images moved. And then they move another one to see which of the other images moved. And they do that so they can map out which image belongs to which mirror. Okay? Then you move them until you get that hexagonal pattern, but individual images still for each mirror. But now you've got them in order. Now you've got them in place. Now you know which one is which. And so now you start moving them in to where all of them come together as one image. And that's where we're at right now, is they have aligned it well enough that you get one image in aggregate instead of 18 individual images. Okay? They've got a little more tweaking to go to get it perfect, but the fact that they've got it there where it's one image is just amazing in and of itself. It's kind of spooky in a way because after Hubble and everything, you kind of got to start asking what's going to go wrong. And so far, nothing has gone wrong. So, it's one of those things that you get a little nervous with all of this.
They've already captured some images already, right? I saw a video today. They were talking about some galaxies and possibly a black hole, maybe. Do you know anything about that?
I have not heard about the black hole spotting, but I do know that the image that I forget the name of the star because it's one of those, yard-long catalog star names that they're using to position the mirrors. But in that image, because I've seen it too, there's only 2 stars in that image. So all the other bright dots you saw in that image are galaxies.
Right.
And people go, well, how do you know it's not a star? It's just a bright dot. Well, if you notice that main star they were imaging had all these rays coming off of it.
Right.
Those happen because of a type of interference we call diffraction. And a star, because it's a point source, it's far enough away and small enough that it's like a dot, a perfect geometric point of light, undergoes diffraction. A galaxy, on the other hand, is an extended body, light coming from several different points, and so the light from a galaxy does not diffract and does not produce those spikes. So if the dot of light doesn't have those spikes around it, it's a galaxy. If it does, it was a star.
Cool.
And so that's how you can tell the difference. It's the same idea behind stars twinkle because they're point sources, so the shaking of the Earth's atmosphere takes them in and out of your line of sight. But the planets don't tend to twinkle because they're extended body and the shifting of the atmosphere can't take it completely out of your line of sight. And so the planets in the night sky do not twinkle, but stars do. And it's the same kind of idea. It's not quite analogous, but it gives you an idea and something you can hang your hat on and say, okay, that makes sort of sense.
Well, do you so like with this I know James Webb is supposed to be able to see or they're trying to see the background radiation from like all the way back to the Big Bang, right? I mean, what can you talk about that for a second?
Well, if our current understanding is correct, which James Webb should help us determine if it is or not, there's only so far towards the Big Bang that we can actually see, because it had to get cold enough that light could actually penetrate. Because that's something a lot of people don't understand. It would have been hot, so it would have been glowing. Yes and no. Because it would have been so dense that each photon, each time one was emitted, it would immediately hit and be absorbed by another particle. So the universe had to expand enough that there was enough distance between all the particles that light could penetrate and get through. So we're hoping that James Webb can either get us back to that light breaking through or close. And that's what we're trying to do, what we're trying to see. And in a way, it's already done. You've heard about the cosmic microwave background, right?
Yes.
That's kind of that's that light from that burst through when the universe became density dropped low enough for light to get through. That cosmic microwave background is that light that's been stretched over 13 billion years. Yeah. So that now it's a microwave instead of an ultraviolet photon. And so, yeah, so we kind of already know that flash, that front is there. James Webb just may actually get us close to where we can actually, see it. It's still in infrared, but wow, that's still closer to being seen than microwaves are. And by the way, you'll hear astronomers talk about light. We're talking everything from gamma rays to radio. To us, it's all light because it's all electromagnetic radiation. So to us, it's all light. It's all really the same thing.
So James Webb is it's also supposed to be able to look at exoplanets too, right? And possibly,
that's one of the hopes, possibly.
Right. And because the way they do it now is kind of not primitive. I mean, it's obviously a modern way of doing it than it was back in the past. But like when a planet would pass in front of a light, we're going to get to a famous star here shortly. But like when a planet passes in front of a star, the amount of light that dips, right? It kind of determines. Right. They use that to determine.
That's one of the detection methods. In fact, I've done that.
How does that work?
Okay, and it's basically, think of it as you've got a light bulb on your porch. Okay.
Mm-hmm.
And you've got it set up with you back off half a mile, and you've got a camera looking at that light bulb, taking lots of quick flash pictures, right?
Mm-hmm.
Well, now let's say a big moth flies in front of that light bulb. The camera actually will detectably, if you run it through the analysis and measure how much light each pixel on the camera's CCD, if you measure how much light was there, the camera will actually detect the dimming of the light bulb from that moth passing in front of it.
Mm-hmm.
And we do the same thing with the planets, because the planet has no light itself. It blocks part of the star. And so the light from the star dims.
Okay.
And we can actually detect that. I've done it myself on several occasions. Used a telescope, used the CCD camera, and been able to detect that slight dimming from a planet moving in front of the star. And it's not an easy thing, but it's not that hard.
Well, that's the current method now, right? But with James Webb, though, isn't it? They're using different methods to.
They're going to use that method still, but they are hoping to get some direct images.
Oh. Wow.
Okay. Because it's kind of hard to sketch here in the air, but the light given off by a star follows what's called the black body, which means it rises up in the blue and then trails off and then tails off into the red. So over here in visible wavelengths, the contrast between a planet, which is very dim compared to a star, the contrast between the two is very high. You get a lot of glare. But over here in that infrared, the tails are closer to each other, so there's not as much glare. And so what we're hoping is James Webb will actually be able to take an image of some of these planets in infrared. Now, what are we going to see? We're going to see its atmosphere and clouds, right? No, we're going to see a little dot. Okay? But a little dot beats a bowl in a light curve.
Right, yeah.
Okay?
It's a step up, for sure.
It's a step up. And that's what science is about, is we're going to take baby steps and go from this thing we know and take little steps to get way over here to things we don't know. And that's what it's all about. That's what makes it exciting.
I know.
It's making those tiny steps.
Kind of makes you wish you were the Highlander, where you could live forever and see the advancements that would come in the next 1,000, 10,000 years and stuff like that. Because everybody forgets we're like what's the closest star from us is what 2 light years, maybe 6 light. What's the closest star to us?
The closest one right now is called Proxima Centauri. It's a little under 4 light years away.
So, I mean, with the current technology we have, it would take hundreds of years to get there, right?
100, 120, something like that. And then there's the round trip back, This is why,
we're coming back. It's one way for me, brother. Hey, my bag's packed. I'm ready to go. I got my MREs. I'm ready to rock, man. I just need that Highlander longevity.
There you go.
So with the James Webb, though, will it be able to detect black holes too? Because I have a question from the chat from Miss Jimmy here in a second. Will it be able to detect black holes?
I'm not a James Webb practicing scientist, so I can't say with 100%, but I would imagine it could.
Yeah.
It's not going to show the black hole itself. What all of this stuff that we've got, like the image of the black hole that was taken a few years back, it was not actually visible light or even infrared. It was patched together from radio waves. Okay? So, but remember, to us, it's all light. Okay? It's just a different wavelength. So that was put together from a lot of radio wave data, and it's not really seeing the black hole, it's seeing the disk of material around it. And so you get that nice warped shape to it because of the weird things black holes do to the gravitation, due to their gravity, due to space-time around it. So what James Webb will be able to do is, because it can see through all the dust and everything, it should be able to see these little disks of material around these black holes. And that will be what it sees. But, of course, that's seeing the black hole.
Will there be if we ever get close to a black hole, will there be a red giant robot that's in a spaceship and
Maximilian, stop him!
That's a reference to a Disney movie called The Black Hole Kids from the 70s. So black holes are pretty fascinating too. Since now we've learned a little bit more about black holes. Now there's some hypotheses about what a black hole can do, right? I mean, okay, so we know that nothing can escape it, not even light. You got to throw that obligatory thing in there. Like, nothing can escape, right. And then you hear somebody like 4 miles away, not even light.
Not even light.
Do you have to say that? We know, we understand. But is it, I mean, are there any plausible theories that it's like a gateway to another universe? I mean, yeah, it's probably not a healthy trip, but
right.
What do you think the black hole does?
There's all sorts of current hypotheses about what a black hole does. Because we really can't say what happens inside one. Physics breaks down. That's why we call it a singularity. A singularity has a certain mathematical meaning. It means division by 0. Okay? The bottom line is at the black hole, matter is crunched to infinite density and 0 volume from our current understanding. Well, what the heck does that mean? And the answer is, we don't know. Now, things falling into the black hole. We do know from general relativity and Einstein that stuff falling into the black hole, time slows down. Okay? So as you get closer and closer and closer to that surface, time is going slower and slower and slower. So you fall more and more slowly as you get in close to it from an outside observer's point of view. Well, that means time stops when you reach the surface. So how can anything fall into it? But we observe that things fall into them. There's just a lot of unknowns about these things because, you know, our observations of them are still in their infancy. Our understanding of what gravity actually is, or what it's actually doing, our current understanding is from general relativity, and it's only 120 roughly years old. You know, good old 1905 was when Einstein, I think it was 1905, maybe 1908. But anyway, it's roughly 120 years that we've had general relativity, which has given us our best understanding so far of gravity and what it is and what it does. Yeah.
What about white holes? Is that just like a myth, or is there any like scientific basis?
Wonder Goon just asked the same question, and in chat, I noticed that, and it's a good question, and the answer is we have observed none to date. They are a hypothetical. Hypothetical. That's not the word. Yeah, it is. Yeah, hypothetical possibility, because curving space-time, as general relativity says happens, there is the possibility that you could punch a hole through and come out somewhere else, and that would be a white hole, where black holes are taking everything in, and it's blowing through this hole punched in space-time and blowing out in another location. And so that's kind of what the hypothesized white holes are, is essentially the exit of material that was swallowed by a black hole.
Right. So
we have observed nothing that.
But it's all theoretical, right? It's not.
Right.
It's not even theoretical. It's kind of like you guys have just kind of bandied that about, right? Because I mean, it would make sense if that was the case.
The math says it's possible, but we've not observed anything of the type so far. You know, but for a long time, black holes were hypothetical and possible by the math, but until Cygnus X1, we never saw definitive evidence that, yes, these things exist. So who knows what will happen 10 years from now, much less 100.
I know, right? So one more question about Hubble. So how far is the telescope from Earth now, and how much further does it plan to go compared to Hubble?
Okay, James Webb is in its position. It is not going to go any further away from Earth. Let me see just how far that is. To James Webb.
It's in like some L2 zone, right?
That's exactly where it is.
But yeah, I'm not quite sure how far that is out.
It's roughly 1 million miles.
Oh, okay.
So it's about 3 times the moon's orbit out there. So, you know, get to the moon and you're 1/3 of the way there, roughly.
Oh, okay. So the moon is like moon's like a gas station. You stop off, get you some beef jerkies, maybe a.
If we build a base there, absolutely.
Get Mountain Dew Code Reds there, and then you got space truckers, man, heading out to go. Yeah, because if something breaks on that thing, you need somebody to go out and fix it, right? So. I'd love to. We talked about this a long time ago about the plausibility of having moon bases, and you said like the moon dust is just too much. It would just get into everything, right?
Yes. We have better ways of combating that now. But the thing about moon dust is it's not dust like you have in your house. It's from rocks being broken up because other rocks slammed into them. So it's like little shards of glass.
Oof.
And so it's fixed to things like Velcro because it's got little jagged points that dig in and hook it in. So that is actually one of the problems with a moon base is when you go out, you got to get all that dust off of you. Because otherwise it comes in and gets caught up in your nose and then in your lungs, and that gives you cancer, because that's the problem with asbestos. It's little needles that get in there and stab in your lungs. It gets into the air filtration systems, it gets into the water, it gets into, it comes inside with you, and then you can't get rid of it unless you find a way of getting rid of it. And we're pretty confident we've got ways of dealing with that around now. So,
I got an idea. Space shop vacs or dustbusters. We would so die on the moon. I don't even. Yeah, it would be awful. If Wonder Goose says moon dust is like space herpes. Okay, yeah, sure, but that's like instead of like on your mouth, it's like all over your body.
All over you.
Full body herpes from space. I think that was an Ed Wood movie too. All right, so this is one. This
it's Ed Wood.
It's Wood. Yeah, he said it. But no, you're all right. We knew we were going to go there. We knew this was going to devolve. It's just a matter of time. So, one of the last things I want to ask you about here, we've been flying. We've been doing this an hour and a half, brother. This is good stuff.
Yep. This is cool. I like doing this with Wonder. I do a show with him, similar ideas. So.
Oh really? Oh well. I'm glad you made time to come and be on my little piece of loveliness show. So I thank you for that. So, this always astonished me. Tabby Star. Now we were talking about exoplanets a little while ago, and how when it passes in front of a star, the light dips, and they measure that to determine like how big a planet is, that sort of thing. But with Tabby's star, it's a little different, right? So, just a little backstory here. In 2015, an abnormal dimming pattern of the star KIC 8462852 was noticed by a research group headed by Tabitha. What's her name? Boyajin. It's located. It's about 1,480 light years away in the constellation Cygnus. And so, because Tabitha was, she was the lead on that group, right? So they named it Tabby Star. Now Tabitha Boyajin, right?
She was a postdoc at Georgia State University when I was getting my master's degree there. Amazing lady, very smart, and it was great working around her. I'll put it that way. And I also know another gentleman who was on the team that was working on that star. His name is Bill Keel, Dr. Bill Keel. And so I know him as well. And so I know at least two people who were working on this particular project. And yes, they did call it what? WTF, where's the flux? And, it also silly. It also stood for something else, because for a long time they had no idea what was going on with this star. And so WTF summed it up, where's the flux? And what the,
So now that this was no ordinary star, well, not so much the star, right? But it was what was passing in front of it. So,
right.
Just tell us the anomaly that was discovered, or at least like how abnormal it was. That was what was going on.
Well, normally looking at the things that cause stars to dim is two stars going around each other. They will dim each other, and their light curve will be like a roller coaster going up and down, where one's a deep medium when the dimmer star goes in front of the brighter, and then there'll be a lower dip when the bright star's in front. Okay? So that's one way you can get dimming in stars, is binaries going around each other. Okay? You can also get them from planets transiting in front, and they get kind of a bowl shape dip because a planet is much smaller than a star. So it moves in front of the star, sits there for a little while blocking the same amount of light, and then moves off. So it drops, stays steady, comes back up. That's what a planet curve looks like. Then there's regular clouds of dust that can sometimes come in, but again, they follow a fairly regular pattern because they're in orbit and life is good. All right? What Tabby Star was doing was, in fact, if you called back up the link that you had, if you've still got it.
Yeah, hang on a second. I got it.
Okay.
Where's Tabby?
Because if you scroll down a little further, you'd actually see the light curve, if I'm not mistaken.
Just a second here. Okay. But
sorry to put you on the spot, but I wanted to show it if I could.
Well, you're the scientist. I'm bending to your will. So,
okay.
But the big anomaly about this was the amount of light that dipped, right?
Well, the fact that the amount of light that dipped, it varied. Okay, if you scroll down, keep going. There's a white graph that was just beginning to pop up when you shut it off.
That's right here?
There. Yeah, that. So that's the brightness of the star, the normalized flux. If it's as bright as it's normally supposed to be, it'd be 1. Okay? And as you can see, there's all kinds of dips. They're in no regular time frame. They're very in depth. Okay? So this is not 2 stars going around each other and passing in front of each other, because that's regular in time and regular in depth. Okay? It's not a planet because it's not regular in time, and it doesn't drop to a certain level and stay there and then come back up. It's not a variable star because those are fairly regular about how they dip as well. So, WTF? What could cause this? And it took a lot of observations from a lot of different sources, a lot of different places, to finally figure out what's going on. And so because it was so unusual, people floated around ideas. Maybe we're seeing evidence of another civilization that's building a Dyson sphere around the star. Maybe we're seeing evidence of another civilization where they've built a cloud of satellites around their star. Maybe we're seeing who knows what. But what it turns out is it is indeed gas and dust, but it's in blotches.
Right.
Sometimes you get 2 that are together and dim a lot of the star and it dips down low. And then sometimes it's just one blotch and it dips a little bit. And because they're moving at different speeds, the time sequence is off. There's no real timing that you can get out of it. So, or actually they did, but it took a really long time of observing it before they realized, this is repetitive, it is regular. So it is something in orbit around the star.
Now, the interesting thing about this is, like, scientists don't play, right? They don't clown around when it comes to this kind of stuff. So for them, to even ponder that it could be just like some sort of intelligent life with some, like, artificial structures going around a star, even for them just to contemplate that in the slightest is kind of huge, right?
Right, and it was. And I just got asked by Wondergoon, would this indicate a new planets are forming? In this case, it doesn't, because the star is old. It's an older star. So planets aren't forming, but it is likely where planets didn't form, and it hasn't dissipated yet. Okay? Because eventually a new star will blow off all the gas and dust around it. And so this is probably gas and dust that was left over from maybe planets forming It just hasn't been blown off completely yet.
Could it be like a really? Could it be like a really thick ring around it that maybe that is like not like a solid ring? Or
could be something like that, except it would have to have denser nodules in it, bumps in it, if you will. But yeah, you're right. I mean, scientists were playing around with the notion of we're seeing something weird enough that this could be signs of life.
Well, yeah,
scientists were saying.
Because they were ruling everything else out, and so that was like the last thing they got to. It was like, well, maybe it's this, you know, and they never do that. They never do that.
The previous time that it had happened is the discovery of what's called pulsars, and a pulsar is a neutron star that spins very rapidly and has two jets of radio waves that come out from its magnetic poles. And if that one of those jets passes our line of sight, it produces a very regular radio pulse that we can make up. And so this regular, spot-on timed pulse of radio waves kept coming at us when the first one was discovered, and people go, holy crap, the only thing that can produce something that regular is artificial. And they discovered, oh wait, there's a star there where it's coming from that flashes real bright every now and then, and it's in time with that pulse from the radio, and it's a pulsar. Got it. Okay. so that's kind of the same thing happened.
I mean, I just always I don't know. I was a big fan of listening to Art Bell and his show Coast to Coast and his later shows, you know, and he would talk. He was very, like, towards the end of his life, he was very excited about this discovery of Tabby star and, you know, what it could be. And I mean, so like, what is it? I always call it the Kardashian scale, and that's not right. Is the what is it, like? There's
Kardashev, something like that. Yeah, I know what you're talking about.
It's the three levels of advancement. Like, there's like a type 1 civilization, there's a type 2 civilization, and a type 3 civilization. So
Kardashev scale.
Bless you.
Yeah.
Kardashev. So in order to, if it was artificial structures around this thing, would that be like a type 2?
That would be a burgeoning type 1.
Oh, not even a type 2? Were you using? Because I thought like so type 1 is using.
Or I think it's type 1.
It's like using.
No, you're right. It's a type 2. Type 1 is using all the resources of a planet. Type 2 is using all the resources of the star. So it's a burgeoning type 2.
Right, and type 3 is like using the resources of a galaxy, right?
Right.
Yeah. Fascinating stuff. I feel like we're science officers tonight. Well, you're the science officer. I'm just a guy in the red shirt that's going to get killed on the planet later. Speaking of which, let's talk about. Let's talk about, like, have you ever seen that show, The Expanse? Do you like that show?
I have not yet sat down to watch it.
Dude, you gotta watch The Expanse. Because, I won't give you spoilers, but it kind of gives the most realistic idea of what, like, the future will be, like, 150 years from now, how, like, space travel is, and, like, the physics of it and stuff, and the places that we can go in the solar system, and it's quite fascinating. But
I've heard good things about it, and I do have it on my radar. It's just, you know, I come home, I pretty much want to go crash in bed, read a few pages in my current book, and die.
You're a granddad. I understand that. It's fine. But if you ever get a chance, it's totally fast. Or at least you know what, they're based on books. I can't remember the author's name, but you might be more interested in the books instead. And then maybe if you have time later, you can watch the show. But I hear
that's a good idea.
Yeah. Just look up The Expanse. I can't remember the author's name, but there's like 5 or 6 books, I think, something like that. I think you'd be totally into that. But I want to know, like, your opinion of what are we? Now, scientists, do you have to be grounded in like evidence and numbers and stuff that you can prove, right? So,
right. It is both the strength and weakness of science that we deal primarily with what we can put numbers to.
Right. So, that being said, though, like, okay, so I want to talk about extraterrestrials. Okay, like possible life in the cosmos. Okay.
100%.
You think so? Well,
absolutely. They're out there.
But there was I've got brain fog. But somebody was talking about the mathematical equation of like of all the stars that have planets and all the planets that could possibly house life. There's like millions of possible life breeding planets. Do you think that Earth is being visited like now, like in the past?
That I believe is a 0% chance.
Really?
Yeah.
So what do you think people are seeing in the skies? These like UAPs they call them now.
Okay. Not to try to piss anybody off, but I think a lot of it is people imbibing too much in substances. I think a lot of it is seeing a pattern in what is a chaotic phenomena, where we humans are really good at that. And so you see some lights in the sky. They may have no association with each other whatsoever, but we see them moving in a pattern. Okay? And sometimes just that it was a known and normal phenomena that the person seeing it just did not know what it was. Okay? And then there's a small percentage that even I will say, I have no effing clue what that is, but I still do not believe it's extraterrestrials paying us a visit. And I have, when you stop and think about it, there is no chance for FTL, faster than light travel, okay, on our horizon. Okay, that isn't even bleeding edge science. That's, holy crap, we're not even on track for it yet. Okay, even if you could go the speed of light, we've kind of already discussed that the nearest star would still take you nearly 4 years to get to.
Right.
Okay, so space is huge. Even at light speed, it's huge. So while I believe there's 100% chance that there's life out there and that there's in fact intelligent life out there, I just again have to be pessimistic that we'll ever get out there, much less that anybody else is coming in. I would be the most ecstatic person in the world for you or anyone else to prove me wrong on this. If the alien showed up on Washington Green tomorrow, I'd be one of the ones going there. Mainly because I hope they think I'm a neat pet. Because I will tell you real quick. I will tell you real quick. They crossed interstellar space. We're doing good to cross the ocean.
Well, some of us are good crossing the street. Yeah.
Right. I know who my money is on as far as the outcome of this situation. Oh, but they'll be so much more advanced than we are. They'll be happy and teach us so much. Yeah, how did that work for the Native Americans or the Australian Aboriginals?
Well, there are legends throughout cultures around the world, like from native cultures that told of the sky gods.
Right.
And a lot of them are similar stories. Mariana in the chat says, me and my BFF at the time saw something in the sky. We saw the same thing. She followed what I saw in her car. I did not tell her where it was going, and then it flew to beyond the stars. She told me after it was gone that she had not been looking where she was driving.
Okay.
Cool. So now I used to be like, like Super X-Files, like, yes, it's definitely things that are from outer space. So, but I've kind of I'm kind of hedging my bets now, because I do believe that some of these things are experimental craft that the military is working on. Okay.
Right.
But I do kind of like the theory. You ever heard of Graham Hancock?
I have.
Okay, so
I have read his book "Chariot of the Gods," as a matter of fact. So,
well, that was
I'm familiar with
that
Hancock.
was was it Chariot of the Gods?
Not,
I thought that was Zachariah Sitchin.
Oh, Fingerprints of the Gods.
Fingerprints of the Gods.
Yes.
Well, he mentions that he doesn't think these craft and whatnot are from outer space either. He thinks they're from Earth, that they're like from ancient advanced technologically advanced cultures from way back that somehow managed to survive.
Right.
You know, which I find that fascinating.
And he makes some compelling arguments.
Right.
Some of them I have since found are wrong.
Right.
But it is enough to make you go, And I will say the same thing about aliens paying us a visit. It again falls into that category. I don't believe it. Convince me. You know?
Okay.
Show me something other than blurry pictures and Bigfoot type stuff. Let's have some physical evidence.
What about the Phoenix Lights from the mid-90s? You know about the Phoenix Lights?
Yeah, I know what you're talking about now. And again, there's a small percentage that I will be right there with you going, I don't know what that is. I have no idea what that is.
So the official story, it was flares or lanterns or like Chinese floating lanterns, but
I've seen flares and floating lanterns, and that wasn't it.
These were too uniform. These lasted too long, and there's side stories to. You've seen like the famous video of like the big lights in the sky over Phoenix. But there's also side tales from witnesses who claim that they saw like this huge triangular craft, like it was like a mile wide or something, and it just floated overhead, no sound at all, just quietly. As a scientist, how can you explain something like that? I mean, okay, let's say for example, let's go with the let's say with the experimental military craft. Can the military build something a mile wide and float in the air that doesn't make noise?
No. Not a mile wide. No.
That would have to defy the laws of physics, right? Something that huge would need like incredible thrust to keep it up that high.
It would essentially have flattened everything below it.
Right.
That's one of the problems. That's one of the problems with, as a scientist, Independence Day. Love the movie. But the city-sized aircraft sitting above the city, they wouldn't have had to blast them. Just the downward pressure to hold that thing up would have crushed the city beneath it.
Right. Yeah.
Okay? Because Newton's third law, every action has an equal and opposite reaction. So for something to be holding it up, it has to be pushing down with an equal force. And so it would have crushed the city underneath it.
Unless instead of having force being exerted downward to stay up, something could have been pulling it from above, right? But
always a possibility. But
that would take an incredible amount of energy too, right?
Right.
Either way, it would take an incredible amount of energy. Thrust or pulling it. So
of course, they were able to generate that kind of energy because they were able to build a shield that deflected a nuclear explosion. So, and
as Roland Emmerich, so you know him. He likes his electric lettuce, and so
I better recall that, but that's good.
Dude, man, like we could get the moon to fall out of the sky. What? Fuck yeah, that's called a movie. Tippy tappy. But I mean, stories like that, the ones they always say, like there's thousands and thousands of incidents that's easy to explain or not, or relatively easy to explain, but it's like that 1 or 2% that you just don't know what
that I
the
don't,
hell
that
it is.
I'm willing to agree. I have no clue what the hell that was.
Don't you guys? I figured you guys are like those guys from The Big Bang Theory, right? You know, you all go to lunch and you talk about like nerdy stuff like that. Like, man, where do these things come from? Because you have to be kind of talking about it, right? I mean,
yep. And we do. I mean, I've never been in a group of 3 or more astronomers, honestly, where the topic of what to do in the coming zombie apocalypse has not arisen as part of the conversation. Okay? We do talk about this outlandish stuff. What would you do? How would you do it? So forth. We talk about the outlandish stuff in science. How would you go about testing this if this is what's going on? Thinking about these types of things is what we do. I mean, it's part of the job. At the same time, getting us to agree on anything is absurd. Okay, it's worse than herding cats. And if you don't believe me, I invite you to go to a science conference and watch a few of the presentation and stick around for the questions and answers session after the presentation. Okay, because you will get shredded. Or I say your work will be shredded, okay? Because that's something you have to learn to do too to be a scientist, is you have to distance yourself from your ideas, because your ideas are fair game. You, on the other hand, unlike what Zoidberg says, you do bad science and you should be ashamed. We don't do that very often.
Boo, you do bad science. Well, listen, man, I appreciate what you do, and I wish I if I had a time machine, I'd probably go back and I'd probably get into this kind of stuff, but but then I'd probably be pulling my hair out, and because I want to know all the answers, and I'm too impatient. I got one last question for you.
Okay.
This is kind of a silly one. What's under the ice in Antarctica? Let's go. We're going to make it back to full circle. What's under the ice in Antarctica, and was it Atlantis? Okay.
It may have been. It won't be now.
Well, it'll be Flatlantis.
It'll be flat. It'll be scraped clean. We are not going to find the remains of an ancient city underneath the ice, unfortunately, because yes, it would have been scoured and scraped clear. And as a case in point, my studies in Cleveland, Ohio, the last ice age, the ice sheets came down that far. Mm-hmm. And I have seen the soil depth in that area is only about yay big, deep. Below that, it's all sandstone rock.
Right.
Okay, because the ice scraped it all flat. Unfortunately, we'll never know in Antarctica, because with the ice all melts, it still would have been scraped it all flat.
Yeah.
So sadly, I will say, yes, Atlantis may have been in Antarctica.
Well, the reason
even if it melts completely, we still won't know.
The reason I asked that is because Antarctica wasn't always at the bottom, at the south.
It wasn't always
I know there was Pangea and all that stuff, but I mean, wasn't there like a polar shift or something, or like something?
No. And just the Earth was at one point, at several points, it was warmer. So as little the ice sheets started forming as little as, I think, 12,000 years ago.
Yeah.
Okay. So, humans have existed in roughly modern form for 100,000 years. So this is one of the compelling arguments of Graham Hancock. I will agree with him or anybody else. That's plenty of time for civilizations to have risen and fallen, in a nice cycle. Am I saying that's what happened? No. But I'm saying, it's plausible. It's not something that I can just have a hand go, no, didn't happen.
Right. We just got rated again
Yeah.
from Twitch. Radical Leftist Agenda. What's up, Nikki? She brought the barbarian horde with her. Good for you.
Oh,
lady.
so that's what's going on. That's where all the flashy stuff is coming from. Yes,
Les
I'm watching on
Bones.
Twitch.
Les Bones, what's up? Oh yeah, very good people. I love my peeps that come. I appreciate everybody that comes up. You okay there, Tauntaun? Do we need to cut you open and put Luke Skywalker inside you? You okay?
I can see. Yeah, I'm okay.
You having some of that electric lettuce, Dad? That's good stuff.
No, my lungs are just worse than they were when I was a kid too. So, and you know how bad they were then.
I tell you, I was a smoker for a while, and I quit smoking last year. So, best thing that ever happened to me. And I know you've never been a smoker, right? So, you know, well, but I do understand bad lungs. So yes. I wish you much success in getting those better. So
we're trying. Go ahead.
One more thing. Always one more thing. You got time for one more thing? I don't want to keep you till. Okay. So I know I mentioned the multiverse earlier before, and
okay.
That's kind of an interesting topic to me, where people think there's like another universe, like a mirror universe from Star Trek, you know, the goatee spot.
Yep.
But that there may be
ever evolution. There's one man with a vision.
Die soon and fail. It's like die soon and fail. I think that's the mirror universe. I made that up. That's not the mirror universe. But there. What are you scientists saying about the multiverse, and is it plausible?
Most of us say it's not testable, so it's philosophy. Okay,
yeah.
And so any discussion that we get on this, I will say up front, we're speculating. We're into philosophy now. We're no longer into science. The science does say it's a possibility. It's like I recently had a discussion with one of my graduate students on a similar subject. My own feeling is that there may not necessarily be multiple universes, so much as it's kind of like a radio tuner. We're focused in on one signal out of the universe. And if you could change that tuning dial, you'd shift which of the possibilities that are out there you're actually tuned into. Okay, so if you're asking me personally, yeah, it fits right in with what I believe goes on, because quantum mechanics honestly does tend to say not only was Einstein wrong, God plays dice with the universe and he occasionally changes rules. Okay, so with that in mind, chaos is around us, and anything is possible. Just certain things are more likely than others. Now, that's not the multi-universe theory. The multi-universe gets into that there are actually other universes out there with other laws of physics, and where all these constants that lead to the universe we see and we feel around us and that we inhabit would be completely different if one of these fundamental constants was changed. And so that's what they believe is going on with the multiverses. I've seen no evidence of such a thing, but it kind of has a satisfying fit to it. But again, this is getting into philosophy. This is getting into speculation. Are they out there? There's reason to believe they may be. Are they there? Who knows? I'll tell any student that brings up this, I will look at them, pat them on the back and smile and say, go win your Nobel Prize. Because if you can prove that they exist, or even firmly demonstrate evidence that they are out there, you don't have to prove that, yes, it exists. Just demonstrate that it's more than just some speculations from some pretty mathematics. You've probably won a Nobel Prize. So go for it. Absolutely. Hold on to it, figure out how you can test this, and go do it.
Yeah, I mean, you won a Nobel Prize and you found a new vacation home.
Absolutely.
You know, I just want to go to the universe where there's a successful version of me, and I can go. So, you know, that's my goal in life. Is that if we ever find multi-universe, that's the first thing. I'm like, where's my rich alter ego? So,
absolutely.
So, Rob, I think I've kept you long enough. I'm definitely going to get you on again in the future because we got more to discuss. This was just round one because we have so much science. I love talking science stuff. I really do. I think it's fascinating. And I like talking to people to know what the fuck they're talking about. You know what I mean? So, you know, it's one thing
I don't know about that, but I try.
It's one thing to, like, you know, mess around with your buddies and, like, talk about, hey, man, you know, does Bigfoot exist? I don't know, man. More mushrooms, please. You know, it's like one thing, but then when you're talking to somebody that's, like, actually studied physics and knows, like, all the subtle nuances of, like, how things work in the universe and stuff like that, and the new things that you guys are learning every moment, it seems.
All the time, it seems. Yeah.
I definitely want to I want to get you back and talk about new stuff like the James Webb telescope. Like you said, it's the next step, you know, and I think for definitely for scientists and folks who are curious like me, you know, we always want more. We want to know more about the universe.
And I encourage that. There. Go out there and learn more. Yeah.
Learn more.
Go out there and learn more. Ask questions. Read books.
There's nothing wrong with asking questions. Find out. I mean, and not just about the universe, just about yourselves, about your communities, about things going on around you. I think there's so many people that are in the dark now about what's going on that they'll just believe anything that makes them feel comfortable, and we can't do that. You know, we have to get outside of our comfort zones and find truth, no matter where it is. You know. So, Rob,
Metallica did a song about that.
I know, right?
Sorry.
So, people can find you. You're on Facebook, right?
I am on Facebook. I am on Twitch. I don't stream very often, and mainly it's me playing video games or discussing a role-playing system that I like called Hero. I haven't done any of that in a long time, though. But I am on Twitch. I am on Facebook. I will take emails. Your promotional material gives an email address that I can be. I won't promise to answer, but if your question is, there,
keep them guessing.
I will respond. There are a few things that I no longer engage in. One is the flat Earth. One is the we didn't really go to the moon. Sorry, I am not going to engage you on those topics. I am not going to discuss it with you. I've learned my lesson that people that bring those types of things up are usually not looking. They're not looking for the truth. They're not looking for an answer. They know the answer. And it's not what I have to tell you. So
Wonder Goon says, promote the show.
And every Saturday, Wonder Goon is right. He is the host of the show, but every Saturday at, what is it, 9 o'clock? 8 o'clock, 8 o'clock, about this time, 8 Eastern, about the same time we started here, we do a show called Midnight Train to Nowhere. And we discuss, again, role-playing games. We discuss mythology. We discuss science. We discuss whatever comes to our devious and
things, as they say in the TV guide. And thanks again, Rob, for coming out. And always a pleasure talking science and just talking to him, period. As always, folks, have a great night. Wash your ass, because the last thing you want to get dirty is Uranus. Good night, everybody.